simultaneous linear equations. And the simultaneous linear equations, I should have put an S there, are a pair of two variable equations that must be solved at the same time to get a result. An example of what I'm talking about is right here. Plus 3y equals 5 and x minus 2y equals 3. So the number of variables, the number of letters will tell you how many equations you should have. Since here we have x and y, that means you have to have two equations. If we had x, y, and z, then that means the question has to provide you three equations. Okay, so the number of variables will determine how many equations you must receive to solve the problem, right? Now, there are many methods of solving simultaneous equations, right? Now, I've listed 7 of the most common: substitution method, elimination method, and graphical method. These are something that you should, and I know that due to the pandemic, we did not cover these last year. But right now, we're not gonna go back yet. We might take March to look at these 3 methods. What we are looking at this month are the inverse matrix method, the diagonalization matrix method, and Kramer's method. Okay, those are what we will look at this month. Now, there may be time, or we will have to look back at number 1, 2, and 3 sometime before you graduate, right? But not this month. I don't think if we have time this month, then we look at it. Now, the last one, number 7, the Gauss-Jordan row reduction matrix method, that you don't find it, you don't start to use it until you reach 6th form. For those of you that will be continuing your education, you will meet this method at tertiary level institutions. All right? Questions on what you have written or what is typed on the screen? Any questions?
So you posted it up already?
No, I haven't done anything yet. Like I said, I wasn't feeling well this morning, and in my weakness, I
okay. Sorry to hear that, man.
And I ended up hurting myself worse. So,
sorry, so first you add, right, and then you take away.
For which thing?
First you sub and first you divide.
No.
Your times.
Each.
Right, sir?
Excuse me?
Your times first, right?
No. Like I said, we're not doing for today.
So because I say 2 and 3, you get 5, right? And then and x take away 2y.
It's not that simple.
Why did you get the 5?
It's not that simple. That's what I'm telling you. We will take our time with these.
So you haven't finished here then?
I haven't even started.
Oh, okay.
This is only theory. Only theory. Okay. Because one of these questions can take you between 10 to 20 minutes to do one question.
What?
Yes. These are pretty lengthy. First 3 methods, method 1, 2, and 3, are probably one of the most challenging topics for high school students. And unfortunately, we can't really go back right now because we're dealing with matrices, and I want to see matrices to the end. So that's why I'm telling you, for this month, we're going to look at 4, 5, and 6, because 4, 5, and 6 deal with matrices, which we were looking at last week. Now, let's see. I need you to see one thing here. Very important situation here. You will need you will need matrix multiplication for this section. And because of that, then I want to look at example 4 here, because it's very, very important, because this step you will be using for almost all 3 methods, for inverse, for diagonalization, and for you will need this process, and you need to understand why it works. So example 4 reads, if A is 2, -1, I'm sorry, if A equals 2, -5, 1, 3, and I there is for identity matrix is 1, 0, 0, 1. Show that A times its inverse is equal to the inverse of A times A itself should give us I, which is the identity matrix. So the first thing we need to learn is what we did last week, which was finding the inverse of a matrix. So you're not gonna find the determinant, then find a joint, then the inverse. You're doing it straight to the inverse. Very important. So A to the -1 is equal to 1 over AD minus BC, open bracket, D negative B negative C A. So remember, A is 2, B is -5, C is 3, I'm sorry, C is 1, and D is 3. So A times D means 2 times 3, minus -5 times 1, which is B times C. Similarly, the A is 2, so the 2 goes way underneath here inside the bracket. The 3 is D, so it goes at the top. The B is -5, but it says negative B, so since 5 is negative here, inside the bracket it will be positive. The 1 is positive here. When I put it as the adjoint, it has to be negative. So I now have 1 over 2 times 3 minus -5 times 1 times 3, 5, -1, 2, right? So that's gonna be 1 over 2 times 3 is 6, and negative times a negative is a positive, so positive plus 5 times is 5, and I just bring down the 3, 5, -1, 2. So this is exactly what we were doing last week. Equals to 1 over 11 times 3, 5, -1, 2. And here you'll notice that you skip a step. So now we have 1 over 11 times 3 is 3 elevenths. 1 over 11 times 5 is 5 elevenths. 1 over 11 times -1 is -1 elevenths. And 1 11ths times 2 is 2 11ths. Any questions